Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry. This is the lecture of IR spectra and number 26. In this lecture, I will again explain you application of IR spectra. In previous lecture, I explained you application of IR spectra, but particularly CS stretching and bending in alkane. Now we will go ahead with CS stretching and bending in alkene. So what happened in alkene? Let us see this. Alkene, they are also known as olefin, is unsaturated hydrocarbon which has sp2 hybridization of carbon involving double bond. So in alkenes, CH, which is already a part of C double bond C, stretching absorption band appears in the region 3100 to 3000 centimeter inverse, which is greater than alkane. This band is sharp and weak, attached to the sharp and strong band of CS stretching of methyl group and methylene group. So the band appear like this. So this band is particularly for C double bond CH stretching, which is always greater than 3000 centimeter inverse. And here we will have CH stretching for in CH3, and this is CH stretching in CH2, and these two bands are less than 3000 centimeter inverse. Okay, so this way we can identify both. Now CH bending appear between 1000 to 650 centimeter inverse. CH in plane bending appears as a strong band in the region 1450 to 1420 centimeter inverse. For trans alkene, CH bending appears near 970 centimeter inverse, and for cis alkene CH bending appears near 700 centimeter inverse. So this way we can identify CH stretching as well as bending in alkene. But you know that there are two types of alkene. One known as internal alkene. That means the structure may be like this. There will be C double bond C but inside or in the chain. In this alkene, C double bond C is not at the end of a chain, and it is known as internal alkene, which does not show double bond CH stretching if there is no hydrogen. Attached to carbon of C double bond C. C double bond C stretching shows weak band at 1680 to 1620 centimeter inverse. Now, second type of alkene is known as terminal alkene. Here, the structure may be like this. When C double bond C is present at the end of a chain, it is known as terminal alkene. It shows C double bond C stretching between 1680 to 1620 centimeter inverse, as well as CH stretching between 3100 to 300 centimeter inverse. As for example, one decene, in which we will have bands like this. So this is CH stretching at about 3050 centimeter inverse because of C double bond CH stretching. Here we have one band at 2960, another is at 2850. Both are CH stretching, maybe because of presence of CH3 and CH stretching for CH2. Okay, if they are present, otherwise there is no band. So we have A band, this is B band, this is C band, and there may be one band like this at 1645 centimeter inverse. It is due to C double bond C stretching. This is D band. Next will be at 985, which is CH bending out of plane. Okay, and this is E band. Next would be at 720 centimeter inverse. It is due to CH2 rocking. So these are bands appear because of the presence of CH bond along with C double bond C. Okay, there are certain groups like you may find major bendings of CH aromatic, that is also sp2 hybridized benzene, and if it is mono substituted benzene, then you will find two bands, one at 850, another at 750 centimeter inverse, and this can be doublet. Next, CH aromatic bending due to 1,2 di substituted, that will be at 755 centimeter inverse. CH aromatic appear for 1,3 di substituted at 780 centimeter inverse, and CH aromatic, which is 1,4 di substituted at 810 centimeter inverse. If carbon is sp2 hybridized because of one double bond with another group like oxygen, this is carbonyl group and it is aldehydic CH. Barabar? So this is called aldehydic CH, and that is stretching. Here we will always find doublet 2825 and 2717. Okay, centimeter inverse, and these are doublet because of aldehydic CH. Okay, so this is in general about CH stretching and bending in alkene. That's it in this lecture. Thank you so much.